All right, so I had a student in our online natural building school request a video commentary on this video, and I've already watched it once. It was really interesting. So I'm going to go through the video and we'll watch it together, and I'll make some comments on a few things.
In this video, we are going to show you how earth blocks are made. But if you haven't seen the tour of the beautiful home that was built with these blocks, be sure to check out the link in the description below.
So the video is basically about compressed earth block construction. And just to give a little bit of insight on that, compressed earth blocks are pretty much like miniature rammed earth blocks. Kind of like adobe blocks, but they're compressed like rammed earth would be. And so this guy is building machines that basically make the compressed earth blocks for you. These machines have been around for a long time, but this guy is doing it, and he's going to be leading through the video.
So I'm Ryan Runge. I'm the president of AECT, which is Advanced Earthen Construction Technologies. We've been around for 31 years, making these compressed earth block machines and selling them around the world. We've got machines in actually 51 countries now. Any dirt that has about 10 to 30% clay in it will work for a compressed earth block. Alternatively, you can put about 7% Portland cement in with the mix, and then it will be stabilized, then it will be water.
So he mentioned soil with between 10 to 30% clay content. So keep that in mind, because a lot of people believe they need pure clay to make these earthen materials, which is not necessary at all. You actually don't want to have too much clay. 30% clay is actually very high, and can lead to issues when you're doing cob. Can cause cracking unless you can add enough aggregate to prevent it, but you have to add more aggregate the more clay content there is. So that's good to know. He also said you can stabilize his blocks. He stabilizes with lime. Lime is a good stabilizer alternative to Portland cement. And so he's going to talk more about that here too.
We have stabilized compressed earth blocks that have been sitting in a jar of water for 20 years, and they haven't even begun to erode. The two general ways to build with this material are unstabilized blocks, which is just pure earth out of the ground. 10 to 30% clay generally works, and you'd be surprised. It's generally what already exists in most soils. In that case, the clay is the binder. You can also do a stabilized block using either lime or Portland cement, and you're talking about 7% stabilizer, and then the rest earth. That gives you the benefit that it's then completely waterproof. Depending on what you're after, you can do unstabilized. The blocks are perfectly fine as long as they're covered with a lime plaster or...
So he said 7% lime stabilization. That can usually be either by weight or by volume. I've done it both ways and you get pretty much the same effect. So I've stabilized a lot of earth materials with experiments and with outdoor constructions that are under the elements, and using lime and cement. If you add between 10 to 15% stabilization, either lime or cement, it's basically waterproof completely, but it's also pretty much concrete at that point. So there's a trade-off. I don't recommend stabilizing earth materials for homes and structures unless it really makes sense. Sometimes codes and things will require it though, so it kind of just depends on your situation.
A big porch overhang. Otherwise, you can stabilize them, and then they're completely waterproof by themselves, and then you don't have to cover them. You can just leave them exposed in all their beauty, which obviously the blocks have a really nice look to it. They have a nice color. They look natural. The great thing about this material is it's the structure, it's the insulation, it's the internal finish, it's the external finish if you want to just leave it completely raw. Here in Texas, your house will stay cool all summer long just because there's so much thermal mass. It's kind of like living in in a cave in terms of the climate control. It's accessible, it's sustainable, it's a really cool product. It has a really cool, unique look to it. It's very...
And just jump back here a second. Look at the machine. So he's throwing the raw material in the hopper here, and then it falls through the machine, compresses it, and then they come out on this conveyor belt. That's usually how these machines work. There's also the hand press versions, which you can just pull a lever and then it'll compress the block for you. Obviously, that takes a lot more work than a machine like this. And I think he's going to talk about how many these can pump out.
It's a really cool product. It has a really cool, unique look to it. It's very energy efficient. There's a high thermal mass because it's so dense. We compress these blocks at about 1,200 psi. These blocks are bulletproof. They're tornado-proof. They're obviously fireproof. There's just about nothing that can destroy Earth, which is why there's 1,000-year-old earthen buildings still standing today. Afghanistan, Iraq, those are some of the places they've been building with Earth for thousands and thousands of years. You know, even the Great Pyramids are actually a form of compressed Earth, or at least rammed Earth, if you will. It's a lime-based soil that they compressed and then over 4,000 or 5,000 years turned into limestone, but it started out as lime soil. So even those places have built with Earth and still do build with Earth. This has about 7% Portland cement. The other 93% is just Earth from just down the road. Even if you don't use your own Earth and have to buy from a local quarry, you're still talking about 3 or 4 miles of shipping and almost zero carbon footprint for a block like this. This one's very sturdy. You would swear it's concrete when it's all said and done. We say about 70% of the Earth that we test from around the world is suitable. The clay is critical. Most times you just have natural clay. If you've got enough clay or too much clay.
So he said like 70% of the soil that he's tested is good for his blocks. And that goes the same for what I've found with cob and adobe, rammed earth. Finding the right soil is actually really easy. Most places around the whole world, you can find suitable soil for earthen building materials. The only places I've found where it's challenging are places like Florida, where it's just very sandy, and places like that where you just don't have much clay content at all, but that's kind of rare.
You've got a good problem because all you have to do is augment with some sand. So this is our MX20 earth mixer. This is a huge machine. This machine will process 20 yards of earthen material per hour. If you're gonna make millions and millions of blocks, you would want this machine and 2 of our big 3,500 block machines, and then you have the capability to make almost 1,000 blocks per hour. This is the biggest earth block machine we make. This is called the 3,500. You dump a load of your earthen material here, and it's fully automatic. You press the start button, and earth flows in to the hopper. The tray moves forward. Cylinder pushes the block up, and every 6 or 7 seconds.
So each of these blocks here, you could make a form and then hand tamp as you would do for rammed earth. But each one of these singular blocks would take you, with hand tamping, would take you probably at least 5 to 10 minutes on the fast side. Even if you had a pneumatic tamper, you'd have to pneumatically tamp it in the form and then hand tamp the edges. So it would still take you probably a good 5 minutes per block using a rammed earth form. So these machines are really effective.
And that's a 10-inch by 14-inch block, which weighs about 36 pounds. It's extremely dense. This is the Impact 2001. This one makes 300 blocks an hour, and it makes a smaller block. It makes a 6-inch by 12-inch block. You could build a whole house on just a few gallons of diesel fuel. The tank on this machine is not even a gallon. It's 4/5 of a gallon. You'll run it all day. You can make 2,000, 2,500 blocks in a day on this machine. It's going to go at a little slower pace. Still very fast. Still a block every 12 seconds. You can take the machine to the building site versus shipping blocks all over the place. And potentially you can take dirt that's right there on site and build the blocks and then build your house. So this is
Yeah, I really like that concept. Just being able to take the machine to the site and then use, ideally, the soil from that particular site, or the soil would just be shipped in locally anyway, but just to be able to take the machine and then have the materials locally there, that's awesome.
More advanced spin on a compressed earth block that has holes and is interlocking as sort of a tongue and groove system that where you can stack it really quickly. You can put reinforcement bar in here or run conduit for electricity or run plumbing. This is just straight earth. This isn't even stabilized. This is just 100% earth that we dug up from the ground here. It's made with this machine called the BP714. This was invented by a couple South Africans, George Burlow and Julian Hutchins. This is one of the machines that we make in our shop. This one is going to Haiti. This will be their 4th BP714. They just finished their 100th house in Haiti on a humanitarian mission, and they're even ramping up productions, and they plan to make, hopefully 1,000 more. The first thing that strikes us is that nobody knows about this technology, and the second thing we notice is that when people find out, when we tell them about the technology, 100% of the time they say, why isn't everybody doing this? I mean, they all have the same question. It's too good to be true. It's inexpensive, it's safe, it's healthy, obviously there's no chemicals like a lot of building materials, no formaldehydes and so forth. Really, the only hurdle we can say is that it's just not widely accepted. I mean, it's because governments and coding officials don't know about it, because it's new to them, it's not written into the code most of the time. There's a group here in San Antonio called the Earthen Construction Initiative whose charge is to just advance this as a building material in this country and get it written into the code, and it's going in the right direction. You can build with it in most municipalities. It might take a little extra paperwork, but it's not banned or anything like that. It's just that it's not necessarily written in as a standard building material. So,
yeah, that's pretty much the same story for all these materials like cob and adobe and straw bale, straw clay, hempcrete, rammed earth. It's not necessarily that they're banned or illegal, but you still have to get engineering stamps and approvals because they're not written into the official building codes. And we do actually have codes, official codes for a lot of these, but they're appendices and they're not accepted by most counties in the U.S. yet, at least. It's probably going to take quite a bit of time still for those to trickle down. So, like he was saying, these materials make complete sense to build with, but they're just not widely accepted yet in the building codes, unfortunately. But there's ways around that.
For the time being, it's a little more common in rural areas or kind of do-it-yourself projects, but we're hoping that, that it's going to continue to advance in the direction of being more of a standard accepted building material, and we're doing all the work we can to make it happen. We're actually busy making machines as fast as we can right now. We hope to keep continuing the movement, and we hope more and more people will start building out of compressed earth blocks.
We hope.
Yeah, really cool machines and what he's doing. If I had a machine like that, I would be building with compressed earth blocks. Not for everything, but just the fact that you can put the raw ingredient in the machine and it churns out the blocks at such a rapid rate, it really speeds up the building process. In my view, the main downside to earthen construction is the slow speed of construction. So if there's a way to heavily increase the speed of earthen construction, that's amazing, because it really negates the main downside.